Ahoy there, Sailor Jerry here from Parts for Engines. Going to talk to you today about galvanic corrosion, which is a wonderful science. You can go down rabbit holes and spend hours learning about it. And in particular, I'm going to talk about galvanic corrosion as it affects engine, marine engine, heat exchangers, and the outlets connected to them, which is a real current problem for a lot of people. In layman's terms, the problem is that when you connect your heat exchanger, this is an aluminium one here, a new one, but it's the same with a cast iron one, to an exhaust outlet, you set up a galvanic problem, and the galvanic problem eats away at the aluminium. And we're going to put some pictures up to show you what horrors that can cause just inside here. And that's not a good thing, because these things cost a fortune, especially some of the modern Volvo engines. They're rocket money. So anything you can do to help solve that problem is a good thing. And the problem's caused because this is a stainless steel one, but it's the same problem with a cast iron one. This exhaust outlet is directly connected to the heat exchanger. And often, if you get a Volvo, they use a stainless steel exhaust gasket to go in between. You've got studs there, you've got nuts and bolts. The whole thing electrically is a very good conductor. And that's what sets up the problem with galvanic, and it causes chaos just inside on the exhaust side. So that's the problem. And I want to introduce you to somebody who will be able to explain a lot better than I can a bit of the science. We're not going to go into too much detail, but a bit of the science as to what's going on between these two dissimilar metals. So I'll hand you over to Professor Yaffel.
Hello. Today we're going to be talking about galvanic corrosion. Now, galvanic corrosion is when one metal corrodes when in contact with another metal within the presence of an electrolyte. An electrolyte is just a substance that conducts electricity, like seawater. Now, why does galvanic corrosion occur? Well, as you can see here, different metals have different levels of reactivity. Therefore, a higher metal on this chart is more likely to react than, say, a lower metal. Furthermore, the less reactive metal within this equation acts as a catalyst within the reaction, causing the corrosion of the more reactive metal to become much faster and more aggressive, resulting in the corrosion that we all hope to avoid. This is a big problem for your heat exchanger. As you can see, aluminium and cast iron, the usual materials that heat exchangers are made out of, is much higher on the reactivity scale and thus more likely to corrode. Furthermore, if your exhaust outlet is made of stainless steel, then that difference in reactivity potential is going to mean a much higher galvanic corrosion problem. So essentially we need some sort of buffer between these two metals to stop the process of galvanic corrosion ever occurring. How do we do this? Well, over to Sailor Jerry to reveal Parts for Engines' solution.
Did you like that? So the answer here is to remove the conductivity electrically between those two components. That way, we're getting rid of any galvanic problem. You're not going to stop corrosion, natural corrosion, but you'll stop galvanic corrosion. So what we've developed here at Parts for Engines, having talked to a lot of people who've also done their sort of homemade designs on this, what we hope is a far more professional solution. First of all, the gasket. On a marine engine, this whole contraption, the heat exchanger, the exhaust, should not get hot because it's water cooled. But sometimes the water may fail and it may get hot. We use a non-conductive composite exhaust material, and it's a high temperature one, so it will cope with the unlikely event of you getting an overheat problem. So that will not conduct electricity. The problem you've got, though, is that the studs still will, for reasons I explained before. So what we've developed here at Parts for Engines are these bushers, and these are made from a wonderful material called polyethylene sulfide. It has extremely high temperature capabilities, and it's also very hard to crush, which is important in this system. So these holes here are now drilled slightly larger. These bushes, and we call them top hat bushes because they look a bit like a top hat, the old traditional top hat. They're going through the component, and therefore the stud that comes through is completely isolated from the exhaust outlet. And we've got on the end of it then quite a thick A4 washer and an A4 nut. And that, allied with our composite gasket, means that if you put a multi-tester between that and the heat exchanger, there is no conductivity. No conductivity, no galvanic. We're going to sell them in our website. You're going to be able to buy these exhausts, cast iron or stainless, with the option of having some of these bushes in them. Highly recommend them to you. It's going to help stop destroying inside, which is just in there, of these very expensive heat exchangers. Hope that helps. Fair winds.